Hello, Jim Lynn here. Welcome back to the workshop. I'm back on the 3-leg workbench again, and since last time I've completed the rest of the tenons on these two cross rails. But before I can fit them to the 3 legs, there's some joinery that I need to do first. It's for the BenchCrafted Glide M vise with a CrissCross Solo. Find out what on earth that is next. This is a picture of the Glide M vise made by BenchCrafted, and this is how it should look, and I really hope that mine looks like this when I'm done. The M in Glide M stands for machined, and it just means that this wheel has been machined to a bright finish. Now this large X-shaped device, that's the crisscross, and it sits between the chop and the leg, and it keeps everything aligned in parallel. So I need to cut this long mortise in the leg for that, and also drill the holes in circular mortises for the main screw. So let's have a look at some dimensions. So starting from 1 inch up from the bottom of the leg is the mortise for the crisscross. Now I'm doing a CrissCross Solo, so I just need the long mortise without the retro cutouts at the top. And this mortise is 19.5 inches long, 1 3/4 of an inch wide, and 1 7/16 of an inch deep, and I'll do all of that with chisels and the router plane. Then I need to drill a 1 1/4 inch hole right through the leg from front to back, and that'll take the main screw. Now surrounding that I need to cut a circular mortise. This is 2 3/4 inches in diameter and 1/2 inch deep. I think I've got a 70mm hole saw, and that'll define the circle, and then I'll dig out the waste with the router plane. But first I need to drill this hole. This is a 3/8 of an inch diameter hole, and it runs right through the side of the leg. And it takes a long metal pin which supports the top of one of the crisscross arms. It's set back 3/4 of an inch from the face side, that's the vise side. Now I'm assuming I need to make this as accurate as possible if I want a smoothly functioning vise. Well, that's actually a tall order. You see, this leg is a fat 6.5 inches wide. But I have a plan. Well, here's the leg, and as you can see I've put on the masking tape, and this marks the outline of the long mortise it takes the crisscross. And this 3/8 of an inch hole I've been talking about enters here, and it runs right across the leg here from one side to the other, and it takes this long 3/8 of an inch pin running right through. Now it's not easy to control the alignment of such a long hole, so if I were to try to drill it in one operation, even with a drill press, the chances of it exiting precisely in the right spot are pretty remote. But with careful planning, and even though I don't have a drill press, I'm actually quite confident that I can get this hole drilled accurately. So what's my plan? Well, first of all, I'm going to use a drilling jig, this one. And if I make this as precise as I can, I'll get the start point precise, and the hole will then be as close to square as possible. Now secondly, I only need to drill as far as the inner wall of the mortise, roughly here into this void. So if there is any out of square error, and I stop drilling here, then any cross range error will be a lot less than it would be if I drilled all the way right through to here. Now this leads me to my third point. I'll drill from both sides, like this. Now this will give me accurate entry points, so at least the ends of the pin will be in the right place. Now after all these precautions, hopefully any error remaining will lie within wiggle room conditions. So let's look at the jig again. Now this gets clamped onto the side of the leg like this, with these two marks aligned. And if I make the faces of the jig in the leg flush, that will set the centre of the hole 3/4 of an inch inset from the side, and also at the correct distance from the leg end. So here's how I made it. So I'm going to be using this hand cranked pillar drill, and it is quite accurate, but I have learned that I need to screw it to the workbench for maximum stability. And so in this case I've done it right at the edge of the bench so that I can get clamps on. Now the drill bit is perpendicular to the base plate, so the side of the wooden block in contact with the base plate is now the reference surface. I've made a punch mark at exactly 3/4 of an inch in from the edge. Now lowering the drill to almost touch the mark is the first step in getting everything lined up. Then I can clamp it with light pressure, then tap the block into final position and tighten the clamps fully and start drilling. Now obviously the handle turns the drill bit, but to make it descend into the work I need to use my left hand to apply drag to that top wheel. Now somehow this makes it descend, and it won't descend if I don't apply that drag. I did figure out how it did it once, and it is very clever. Now once I've finished, to get the drill bit out, normally I would reverse the drill to lift it out, but I find that that slightly enlarges the hole, so in this case I'm just lifting the entire mechanism out. Now I can't drill all the way through because there's no guarantee I'll get the drill bit to hit that hole in the base plate. So I'm clamping the jig on a drilling block and finishing off with a power drill. Now I need to check that everything is square. So I've turned the block reference side up, trapped it in the vise and pushed the drill bit into the hole but on the reference side. Now remembering that I always use hollow surfaces to avoid bumps, I'm resting the square on a bridge between the two sides. This looks perfect. Now I need the centre of the hole to be 3/4 of an inch from the side, which means the edge of the hole needs to be 9/16 from the edge of the block. Now I did leave a bit of fat for trimming, and as you can see the end of the blade of the square doesn't quite touch the drill bit here. So I just need to take a few shavings with the block plane until the end of the square's blade hits metal. Like that. Now I need to make a mark on the side of the block to line up with the mark on the leg, and that has to be perpendicular to the centre of the hole. So this is a wee trick with a sliding bevel to achieve that. Right, the final thing I've done to the block to improve security whilst I'm drilling to avoid any kind of slippage is to install these 4 screws. Now these 2 screws at the front are through 3mm pilot holes, and they're set so that they just poke through and no more, and that's to give the block some grip on the work whilst I set the initial clamps. And to back up those clamps I've got these 2 5mm screws, and they're set through 5mm clearance holes, and their job is to be screwed right into the work to hold the block firmly, so there's no chance of any slippage whilst I'm drilling. Okay, I've got the leg clamped firmly to the bench top with the holdfasts, and now I'm going to clamp the drilling jig to the workpiece. So I'm starting by just tilting it slightly so that those pins don't engage too soon. Get it all lined up with a mark just there, and feel for flush. It is. So carefully press down, that engages the pins. Then I'll get the first clamp. I'm going to set that right in the middle, get that as tight as I possibly can. I'm just going to put another couple of clamps on. This is just belt and braces. I'm just got this great fear of everything slipping and my holes going wrong because I'm only going to get one chance at this. So this is probably not doing much, but it's ensuring that we're as clamped as we can possibly be. Right, I'm just going to reposition the clamps. I don't need this central one anymore because I need to get into the hole. These ones I can just reposition so they're a bit more firm. That's it down now. There's a little bit of wiggle room in there, so I'll try and keep it as... I'm hoping that the shavings as they come up will expand and firm this drill bit, but this is the last bit of inaccuracy that I just can't control. So let's give it a go. Already feels quite tight, so let's get them out. Keep going. There we go. I think that is as far as I can go. So I can take the jig off and finish off in the hole because it will self-jig after that. Right, I can get the clamps off. Right, back to drilling. Now this will go right through to there if I let it, so I only want to go down to about this area here. There we go. That's as good as it's going to get. Hoover. Right, that's one hole done. Hopefully we've drilled through to here somewhere, and when I excavate out this mortise, the other end of that hole will be revealed. So now I just need to unclamp the leg, turn over and do the other side. So how did we do? Did the jig prove to be as accurate as expected? Well, I've taken one of the pins from the BenchCrafted kit and put it into the hole to use as a reference. And if I slide the square up until the bottom touches the base of the pin and hold up this piece of paper so you can see that yes, there is a gap between the two at the top here, which means that the hole is not perpendicular to the surface of the side of the leg. Now the gap itself is 3 millimeters at the top, but that's not the important point to measure. This black line here represents the distance between the surface of the side of the leg and the void into which the hole will exit in the mortise in the leg. And that gap there is about 1.5 to 2 millimeters. Now whilst that's definitely significant, but it's not insurmountable. We can do something about that within the mortise when the time comes. So why did this happen? Well, I do remember when I was plunging the drill into the jig, it didn't feel as tight as I was expecting. And so what I think happened is that the wood was a bit too soft for this purpose, and the drill bit actually, although it was a wood drill bit, I think it was a bit too aggressive for that wood, and the result is that there was too much wiggle room inside the jig. Now I get another chance at this because I've got to make the chop for the leg and I've got to do the same process. So before I do that, I'll be experimenting with some harder woods and different drill bits to see if we can reduce this problem as much as we can. And also, this isn't the important thing. The important thing is the position of the centre of the hole on the surface of the side of the leg on both sides. So we need to measure that next. So the question we need to answer is the centre of this hole in the correct position on this surface? Well, first of all, is the centre of the hole the correct distance from this edge? Well, I've got this square set to 9/16 if you remember that from earlier. And I'll put it on this edge. Does it contact metal? Yes, it does. Is there a gap along this edge? No, there isn't. So now I'm confident that the centre of this hole is at least the correct position from this edge here. Now for the other measurement, I'm going to use this small square, reference against this reference side, like that, move it up till it contacts the metal. I've drawn a line there and I've extended the line down this side here. So now we can flip the leg over and do the same process on the other edge. Right, just going to do the same process on the other side of the leg. First of all, the 9/16 measurement, offering the square up. Now it doesn't quite touch the steel pin here, but looking at it, it's a fraction of a millimetre out, so I'm happy with that. The other thing I've done is I've taken the square, brought it up from the reference side up to the pin, made this mark, transferred it down the side. Now we can run the big square between these two marks and see if they correspond. Right, I've got the big square set against the reference edge this time. I'm going to slide it up until my first mark on this side, just till it touches the bottom of the mark. Now I've sharpened my pencil. I'm going to make a line in the middle here, like that, and then move the square. Well, that is actually on that line, so those lines match. So this is absolutely perfect. Okay, so what is the result of our testing? Well, I think that we can confidently say that each of these holes are in perfect alignment opposite each other. which is good news. That means that the jig has done its job perfectly from that point of view. Now, of course, we still don't know what's going on in here, but at least we can say if I can get this pin to run from one side to the other smoothly, then it puts it within wiggle room on the end of this crisscross leg. So that's good news from that point of view. Now what we can do is proceed to excavate this mortise. So let's do that next. Before starting to dig, I went over my marking gauge lines to make sure that they're deep enough. And then off camera I made some new lines inboard of those. I call these rough work lines. You've seen me do this before. It's to preserve my finished edges for as long as possible. Then deepen those rough work lines with a few taps of the chisel. Now it's a good idea to start pushing down grain and work backwards in short bites. This avoids the plane digging in and avoids splitting of the work, and short chips are less likely to get jammed under the mid body of the tool. Now after every few millimeters of depth I redo the chisel lines at the sides and ends. I found it was a comfortable balance of push effort and progress to extend the blade by about 3 turns of the adjuster for each level. When the back of the tool hits the end, just turn the tool round. But this then means cutting into the grain, so short chips are essential here. The masking tape's getting a bit raggedy, and it's served its purpose anyway, so I'm just going to remove it. But there's now an issue with getting more depth of cut. You see, there comes a point when the adjuster knob bottoms out, and we can no longer get the blade any lower. Now it's an easy fix, we just remove it. I've got the masking tape off, so I've got a good clean surface. So here's the router plane without the depth of cut adjustment screw on it or the depth stop. So the blade is free to move up and down, a little bit tight there. Free to move up and down. So to adjust the depth of cut is actually quite easy. Let it drop onto the work, and as you lift the plane up and down you can see the blade stays on the work, sliding up and down the shaft here. So I'll just gauge a little bit of depth of cut, somewhere like about there. Tighten the knob hand tight, but the trouble is it might not be enough to hold it, so I've got this large Lie-Nielsen screwdriver and I'm going to give it a good tight with that. That should give me enough tension to hold that blade. As I push the blade down into the work, there's always a risk that the blade will overcome this screw and get pushed back up again. I don't want that happening. It'll affect the depth of cut. There we are. We're getting a good millimetre or two out of it there. Right, I'm going to stop there for the time being, and I'm not going to go any further with this part of the leg mortise at this point. And you can see I've still got probably 2.5 millimeters still to go. But the reason I want to stop is I've still got the sides to do, and I've still got the rest of the leg to do, and I want to finish off with a nice even surface all the way around. And if I go any further here I might make marks that I can't get out. So I'm going to stop there with this one, and I'm going to carry on with the rest of the leg off camera, just because it takes a lot longer to do it whilst filming. But essentially the process to finish the rest of the leg is just the same as this end. And then once I've got that down to the same level as this, we'll come back and we'll do the finishing off process. As you can see, I did develop quite a good rhythm and speed with this tool, and of course there's faster ways to do this entire job. I could have used an electric router, but first of all I don't have one, and secondly I absolutely hate those machines. They're vile. I would never use one. Another way of doing it would be to hog out most of the waste with a chisel, but I'm not convinced that would be that much faster. And anyway, I wanted to use this plane when the depth of cut was quite big, you know, up past 30 millimeters, because would it be difficult to control? Would it rock? And the answer is no, it isn't difficult to control. It's quite easy and it doesn't rock. But you can only find that out if you use the plane at that level. After bringing the depth of the longer section down to the same level as the shorter section, it's time to do the final cuts on the sides and ends and to bring the whole mortise to finished depth. So to start that process, here I'm undercutting the sides before I chisel them off. This will help stop me chiseling too far down. This job is easy, but we do need to be careful because this will be a finished surface. Here I'm just peeling off the waste, but being careful not to undercut at this point. So my initial process is just to work my way along, dropping the chisel into the knife line and just starting that peeling off process. Here I'm using a narrower chisel just to create a square reference section. I take my time and just work my way along carefully, aiming slightly off square towards the void, and then I can go back and square it all up with smaller cuts. I'm keeping good control with a firm grip with my left hand on the chisel. I don't want that chisel jerking suddenly and ruining the other mortise. It's the same process for the ends, although the hammer is necessary here with that tough end grain, and of course a sharp chisel. Now you'll notice that the chip eventually just falls away. That's because of that undercutting operation that I did with the router plane, and it just tells me when to stop hitting with the hammer. Now the sides are done, I can prep the bottom for the finishing cuts with the router plane. The blade is set just shy of final depth and the last rough cuts are made. In this case, the shavings are so thin that there's no problem taking long strokes. Well, this is the leg vise mortise finished. I have to say I'm really happy with it. It's turned out crisp and clean and it's the correct dimensions, so what more do you want? But there's still more to do in this leg. I've got to correct those wonky holes, and there's the holes in circular mortises for the main screw. But that'll have to wait until the next episode. So I hope you'll come back for that. In the meantime, thanks for watching.